So everybody, thank you for attending this CI Compass hosted webinar. First, I would like to make sure everybody understands that this is recorded. It will be posted to YouTube afterwards. So our speaker today is Brian Lin from OSG and the PATH facility. He is the software area coordinator. And so Brian will tell us about how he manages people, systems, services using the DevOps model. So Brian, thank you for presenting today, and the floor is all yours.
Perfect. Thanks for inviting me to speak, Mats. So as Mats said, I'm Brian Lin. I am I wear many hats, but for this talk, the most relevant one is that I am the OSG software area coordinator. And that means that I am responsible for the software stack that sites around the world install to contribute computing capacity to the OSG consortium. I'm based out of the Center for High-Throughput Computing at UW-Madison. And today I'm going to be talking about the different ways that we try to attain those DevOps ideals that are all kind of the rage these days. So just a short introduction. The OSG consortium is made up of many members that operate pools of shared capacity for the purpose of distributed high-throughput computing. We also have a small staff, and the staff operates the OSG Fabric of Services, provides software distribution, integration, and maintenance, facilitation for researchers and collaborations, being of larger experiments. And there's also a lot more, but those aren't quite relevant to the DevOps stuff. We have a security team. We have a team that manages production and networking and R&D and all that sort of stuff. So where PATH comes into play here, PATH is the partnership to advanced throughput computing, and it is a partnership between the OSG consortium and the Center for High-Throughput Computing. I'm not really going to go into all the details here because last year, I believe, you heard from the man, the myth, the legend, Marone Livni about PATH and what it means for distributed high-throughput computing in general. But the important things to note for this talk is that the HTCC is home to the PATH development team. In particular, they are the developers behind the HTCondor Software Suite. And the HTCondor Software Suite is a really critical part of the OSG software stack. There are many services that we run where HTCondor is at the core of said service. So what is DevOps? Just so we're all on the same page, DevOps to me is kind of a philosophy that you aim for, and it combines software development and operations to provide higher quality software more quickly. And then really what's important there is the goal. And I think that at least in this talk, I'm going to go through a bunch of different ways that we do DevOps, and they're going to fall on a spectrum ranging from the developers and operators being on separate teams across the country to being next door to each other, and then sometimes they're the same people, and that's going to change depending on the project and potentially which part of the code base you're on. So where one of the big services where this has come into play is the OS pool. The OS pool is a dynamic distributed high throughput computing service for open science, and it gets its computing capacity contributed to from hundreds of sites across the country and across the world. And this service, compared to some of the other pools in the consortium, is really designed at smaller research groups, single PIs, that sort of thing, who may not have a home in a larger collaboration, but still need dHTC to advance their research. So the OS pool itself consists of distributed services, and these services are operated by a distributed group of the OSG operations team. most of, if not all of these services are based on HTCSS. And then the end user support and documentation are provided by the OSG research facilitators. And so in context of the Path project, this was really a no-brainer for DevOps, or for DevOps within Path, because we have the developers, we have the operators, and then the folks that are working with the users to help provide feedback and input into the development process. So under the hood, the way this works is that you have your, I hope you guys can see my mouse, but in the top left, you have a researcher that has access to an OSG access point. And they have their workload and their data on their laptop, and then they kind of push things to the access point. Behind the scenes, the OSG has what's called a Glide-in WMS factory, and this is watching this access point for demand. And when it sees demand, it will submit what are called glide-ins to the compute entry point. And each site will manage their own compute entry point, or have the OSG manage one for them. We'll get into that a bit later. And if things all go well, then those glide-ins will be submitted through their local site scheduler. And the special thing about these glide-ins is that they are running HTCondor. And so these glide-ins will start up and report back effectively to the access point and show up to the user as capacity. So I've been talking about the distributed nature of the services and operations in the OSG, and we have access points at UW-Madison and the University of Chicago, and the Glide-in WMS factory is running at UCSD, and there are other parts of the infrastructure that are supporting this that are running at other institutions as well. And also there's the centrality of the HTCSS. The access point is running HTCSS. The glide-ins themselves are running HTCSS. HTCSS is at the center of the compute entry point and at the Glide-in WMS factory. I also want to shout out a different way, a somewhat new way that sites are contributing to the OS pool. We are distributing a container that is effectively a glide-in that a site can start up. Oftentimes this is in Kubernetes, so that they can manage how these glide-ins scale out at their site, but sometimes they're just running Docker on their execution points. And so they can also start up these containers that report back to the access point. So how is this DevOps? So we do have operational teams and the development teams as separate people. That's kind of just the nature of DevOps in that you want to go to battle with the army that you have, right? So we have the dev team that has decades of experience developing HTCondor, and then the operations team that also has decades of experience deploying these services and working with users in this distributed high-throughput computing setup. So before we moved over to this DevOps model, the HTCSS team was releasing about once a month, and what they were releasing, the features and the bug fixes, were designed for the general public. And the OSG operations teams were managing the access points and using the long-term support versions of the Condor software suite. So they were really only getting bug fixes. And in particular, they were generally, trying to stay on top of upgrading to the latest version, but they were really aiming for specific bug fixes. And that's where things moved most quickly. Now that the teams are working together, the HTCSS, or the Path Dev team, they release HTCSS patch releases every Tuesday, and the OSG operations team upgrades the various parts of the OS pool every Tuesday as well. The features and bug fixes that go into these patch releases are planned by the path development team, along with the OSG teams, the operations team, and the facilitators. And so in addition to using these patch releases, they are kind of using the feature series of HTCSS. So they are also getting kind of the latest and greatest features that go into the general public feature releases. And these OS pool specific changes are rolled into those general public monthly releases. So the rest of the world get to see the benefits of this relationship that we've built between the Path Dev team and OSG operations. So looking back at how this process went, really, there wasn't a lot of technical work or policy work to get from the then to the now, the before DevOps to quote unquote DevOps. And really, the heaviest lifts were around new organizational goals and structure, because Path is a partnership between two organizations that we communicated with each other, but there wasn't this formalized relationship. It's kind of akin to a private sector merger in some ways. And so when that happens, you have a lot of new people, new teams working together and trying to understand the context of the new culture that has occurred through this partnership. So one thing to help, so we've done a number of things to help build that cohesion and that culture of working together in this partnership. And there are a couple of things that we do. We have monthly town halls that are run by the Path leadership. And this is a forum to discuss strategic direction and receive input from staff. And really, we want there to be like a feedback cycle here, and for folks to feel that they are invested in our goals and understand the direction and where we're all kind of rowing toward. We also have weekly OS pool operational meetings, and this actually coincides with the Patch Tuesday. So all the parties involved can kind of coordinate what needs to be upgraded and what needs to be changed, maybe in the configuration, and if there's anything that needs to be communicated to users and whatnot. And then we also have weekly all-staff meetings where other areas of the Path groups can get a feel of what everybody else is working on. We also have dedicated Slack channels for day-to-day communications around operations of the OS pool, and that is another higher bandwidth way to make sure that teams are coordinating. And those channels have been, we've seen steady growth in use as the teams get more comfortable talking with each other. And so all these solutions really reflect that our team is distributed across the country, and we have been living in a virtual only world because Path was initially awarded in September 2020. And throughout this, it has kind of highlighted a bunch of weaknesses in our onboarding processes. Because in the past, we would onboard maybe a couple of folks at a time, and a lot of times they would have the local support of people to kind of help them out and learn the ropes, learn unwritten rules and that sort of thing. But this partnership, it was the first instance where there was basically a huge amount of people that were joining the OSG or the CHTC and had to understand the organizational structures and unwritten rules, who to talk to, and all that sort of stuff. And that was, we didn't have much in terms of formal materials for that sort of thing. All that being said, I am really excited for an in-person all-staff meeting, and I believe that we are targeting something for 2023. It's kind of in the plans, just because I'm a firm believer that you need to at least meet somebody once. It really changes the dynamic of the relationship and makes makes you feel more comfortable meeting somebody in person. So we have been taking advantage of all these relationships that we have been building across these teams to attack some special projects. So one in mind that is currently ongoing is that historically there have been parallel developments in different parts of the software stack that added support for Apptainer or Singularity user jobs, basically user jobs in their own containers. This has been difficult to untangle over the past couple of years, partially due to feature disparity between the different software stacks, and then the expertise of the various layers of the software stack are distributed among the different teams. So we were able to take these new relationships and new processes to turn this intractable, seemingly intractable problem into a well-scoped multi-week project.
Brian, if you're about to, just ignore the question, but if you're not, could you give an example? This is a little, I'm not exactly sure what you mean in this slide.
Sure. So, you know, what I've been talking about previously about building relationships, MOTS is actually part of this. And so MOTS has been, you know, coordinating more with the the path development team. And MOTS has historically been kind of the head of OS Pool. He's been managing a lot of the policy and configuration work himself, and has been working on various layers of the scripts in both Glide and WMS and within the OS Pool to add the Apptainer support. And the HTCSS team they have been adding Apptainer and Singularity support directly to HTCondor itself. And so you kind of have these competing development projects that are adding more or less the same thing. But, you know, the work that MOTS has been doing, the Glide and WMS team has been really targeted to OS Pool and distributed high-throughput computing as a whole. And so because MOTS and the HTCSS team have been working together, they're at weekly meetings together, it makes this project a lot easier to take on, to identify where are the gaps in HTCSS and how do we get from the OS Pool and Glide and WMS support for Singularity to just using what's in HTCSS. Does that answer your question, Peter? All right, moving forward. When this is all said and done, the OS Pool users will be able to take advantage of the currently missing features that are not available in the OS Pool, but that are provided by HTCSS in general, just because the way that the Apptainer support is currently deployed in the OS Pool. So for example, because there's basically a job wrapper, and then Condor runs inside of that, the users, Condor offers a feature called Condor SSH to job. And so because of this wrapper and the OS Pool level and the Glide and WMS layer of the stack, that feature is not available to OS Pool users. And this is really important for users to help kind of troubleshoot their jobs and whatnot. You know, and as a result of this work, other HTCSS users will see improvements to the Apptainer support that, you know, that the Glide and WMS and OS Pool teams have added on their end. Changing gears a little bit, in Path, we have something called the Path Facility. And this is basically a nation scale, dedicated, distributed high-throughput computing service. And so there are a couple of sites that are involved in this project: Syracuse, FIU, TAC, Nebraska, UW, and SDSC. And the idea here is that users, researchers will apply to the NSF to get credits in the Path facility, and then be able to make use of this computing resource and have that counted against their credits that the NSF awards them. So what's actually underlying this Path facility? It's about 30,000 cores, and we have 36 A100 GPUs. Each site in the facility maintains the hardware and networking. But for some of these sites, a central Path production services team provisions Kubernetes, the operating system, all of that at various remote sites. So Florida International, Syracuse, Nebraska, Wisconsin. At SDSC and TAC, they provision their own hosts with Kubernetes, so they manage that bit on their own. But then there are also the developers in Path Production Services, and they deploy the distributed high-throughput computing services on top of these Kubernetes, on top of the Kubernetes infrastructure that's distributed across all of these different sites. And each site is maintaining their own, or they're not maintaining their own Kubernetes infrastructure. We deploy the Kubernetes installation on those sites, but they are separate Kubernetes clusters. So to make sense of this, the Path Production Services team uses something called Git Ops. And Git Ops is a way to track and make operational changes with Git combined with continuous deployment systems. So an operator or a DevOps person will make a change, commit that to the Git version control, and then the continuous deployment systems will take that change and apply them to the relevant services. And so really, I couldn't imagine managing this any other way, because these service states are enshrined in history and really allow for rebuilding entire clusters in case of some sort of catastrophic failure. And we've had that happen before, and we're able to rebuild. You know, there were lessons learned along the way, but we were able to basically get to the previous state before said failure. And also just generally with Git, you get to know the who, what, when, and hopefully why, if you have a culture in your team to write good commit messages of these changes, the who, what, when, why of changes, and these are useful for auditing and then knowledge sharing. There are so many times when some operator figures a way to do something, and then we need this applied to another service or something like that. And so that operator can point to the series of Git commits, a Git branch, whatever, and say, oh, just take a look at this, and you can mostly figure it out and let me know if you have questions. And so there's definitely a lot of that. On the technical side of things, this, again, all inside Kubernetes, and we do continuous deployment through Flux, and we do actually keep the secrets all inside the Git repository. So think certificate keys, passwords, and all that sort of stuff that a service may need, but these are all encrypted with something called sealed secret. So basically we have the sealed secret Kubernetes operator running on the cluster, and they know how to decrypt the secrets from the Git repository. And then we use Dex for managing operator access. This is hooked into our co-manage from CI logon, and we assign certain folks they are the operator of this Path facility, so they have these sorts of permissions. So there have been challenges. This is kind of a new and interesting setup. Early on, we had a lot of issues coordinating, troubleshooting hardware and networking issues in this distributed ops environment. And really that was so much of that was kind of just scheduling. We had folks, Syracuse and FIU, having some issues with switches and all of that. And it was just tough to coordinate time with the path protection services team, so where they could sit down for maybe an afternoon and troubleshoot together. We've experienced, especially at SDSC and TAC, that they're slightly different Kubernetes environments, and they may require different strategies for deployment. The clusters at Wisconsin and FIU, Syracuse, et cetera, allow for privileged access, whereas the SDSC and TAC clusters do not. We have to kind of figure out ways around that, and sometimes this requires development effort. And then one other thing that we've noticed, and even this has been noticed by our facilitators and our end users at times, is that this is a relatively complex system, and it can result in difficult to troubleshoot issues. And so we are thinking about ways that we can mitigate this complexity, because this causes issues not just for our facilitators, but for our operators who are potentially also doing that development. And so we've talked about writing operational and architecture manuals, but also at some level, some of this is not just the design of the system, it's just kind of new technologies to our community are kind of complex. Kubernetes is a complex beast. And so there are opportunities to educate those in the organization. And so we're thinking about ways in which we can do that. I'll get into that a little bit later. So in addition to the OS pool and the path facility, we run other services out in the OSG, and we call these the Fabric of Services in the OSG. And these are really it's a variety of central services, and really they are designed to benefit multiple members of the consortium. That's why they're kind of assigned to the OSG staff. And so the OSG operations team, as I've kind of indicated, is they're spread across time zones. So it's important to coordinate work, and we do that in daily stand-ups and also through Git Ops. Git Ops, I think, is most critical. If you're going to take any sort of, if you want to go on the DevOps path, getting on the pulpit here a little bit, but Git Ops is something that I would stress is so important. Many of the services were originally running on bare metal or VMs, but they have been migrated to Kubernetes clusters at University of Wisconsin, University of Chicago. And this has been beneficial for us because some of these services are deployed in kind of a high availability mode. And so we have duplicate services running at the two clusters, and this has kind of saved us in when there has been catastrophic failure at one site versus the other. And many of these services fall on the DevOps spectrum. Some of these services, the operators will write the containers themselves and then deploy them in Kubernetes. But that really kind of depends on what has to be developed in-house versus what has to be taken off the shelf or can be taken off the shelf. So one of those services that is developed in-house is the OSG hosted compute entry point. So from my diagram earlier, the CE provides an entry point and a translation layer for the glidance to run at the local site scheduler. But unless a site has dedicated staff for it, it can be pretty hard for new sites to install and maintain. And in particular, I'm thinking about sites in the CC Star or that are getting CC Star awards. that maybe don't have the expertise of running their own site scheduler, and certainly not distributed high throughput computing services. So we offer the OSG hosted CE as one of our software as a service offerings. And so the OSG operations team deploys these hosted CE Helm charts. Helm is templating around the complicated Kubernetes deployments and kind of makes things a little bit easier for the operator. And it allows sites to contribute capacity to the consortium with just an SSH connection. The Helm chart and the hosted CE containers are developed by the OSG software team. And so there must be close coordination between OSG software and operations. And a lot of these relationships, have been ongoing between the two groups for a long time, as they are both OSG specific. One thing that we had issues with early on relates to kind of the expectations of this service offering. So it's important to understand where your product falls on the DevOps spectrum, and particularly for whom. So the OSG software team was designing this product particularly for use by the operations team. And because of that close coordination, we can do things like make interface breaking changes because we would let them know, and we can kind of plan a deployment around those, or deployment strategy. But early on, there were some other sites that were interested in deploying CEs and Kubernetes. And so they picked up the hosted CE, and that initially worked. But maybe a couple months later, they would try to update. But because there isn't that close coordination between developers and operators, they ran into a lot of issues where things just wouldn't work as expected. Another service that is run in the OSG Fabric of Services is called the Open Science Data Federation. And the Open Science Data Federation is a way that we efficiently move data from different parts of the world to where the computing may be. So it's made up of various data origins that serve various groups, and then caches that are distributed at strategic locations in, say, network backbones, or just across the world. So in the Open Science Data Federation, service deployment is analogous to CEs in that sites can choose to host their own origins or caches, but we also offer it as a service. But it's different here because an important part of caches are that they should be geographically located in strategic positions or network strategic locations. So unlike the hosted CEs that are all hosted in Chicago and the University of Wisconsin, it really doesn't do anybody any good if we host all of the caches there as well. These need to be spread out. So the deployment model here is a little different where we have to deploy caches and origins potentially, or at the site's Kubernetes cluster. And so this has a bunch of different considerations to take into account. The OSG software team is working with the operations team on producing an easy to deploy Helm chart for both the cache and origin. But because, like I said, different Kubernetes environments provide opportunities for development, it takes a little bit more effort and potentially coordination between the two teams to deploy these at different sites. So those charts are currently in progress, but we are working closely with the operations teams to get those pushed out. And of course, I haven't really talked about it in the previous slides, but monitoring is really crucial to any sort of operations in distributed services, but especially DevOps, because you are, ideally making these changes quickly, and then you have to get some sort of feedback on how those changes went before you move forward or decide to roll back. So we have various levels of real-time monitoring, and it's going to be specific to each service. In the Path facility, we use Isinga for monitoring the health of the hosts themselves. Prometheus is what we use in the various Kubernetes clusters to monitor deployments and volumes and all of that sort of stuff. And then we also have a central CheckMK instance, which is really important for remote checks and custom checks against services. So, CEs are kind of a bespoke service, and I don't think Google or Amazon is are running CEs. So we have to have our custom checks there. And then within HTCSS, there's a lot of monitoring data that we use, and we have all sorts of dashboards and email reports and Grafana, Ganglia, and whatnot to keep an eye out on OS pool health, to keep track of those HTCSS patch Tuesdays. And then we also collect a lot of accounting data at sites and usage from users on data and computation, and this kind of serves as a final verification tool in case there are things that our monitoring isn't catching. This slide here kind of stretches the definition of DevOps. But this is kind of what I was getting at before, where I think DevOps is a philosophy where you aim for higher quality software and more quickly. But how close the development and operations is going to depend on the use case, really. So in particular, there were sites in the consortium that were interested in shorter software development and service deployment lifecycles. So the OSG software team packaged many of the services that we offer as containers instead of RPMs, because part of the deployments that these sites were interested in were kind of Kubernetes or containers based. And the reason that this is a stretch of DevOps is it's kind of a traditional, it's closer to a traditional development model, where the developers are OSG staff and the operators are, say, administrators for the US Atlas project. And so they fall under different administrative domains. But we found ways to move towards a tighter or shorter development and deployment lifecycle by replacing some of that tight coordination with clear published policy about the containers that we're distributing. So we have policy that is published and available, and we let folks know about it. We have different container tags that carry different versions of software, and these container tags indicate the level of testing that has been performed by my team. So we have tags that are labeled as kind of development only. And this means that we haven't really done any testing whatsoever, but this may be useful for sites that want kind of the latest and greatest feature, and they're willing to take the risk of interrupting their stability with a piece of software that has not been tested. We also, what's very important about this, about the way that we tag our containers, is that we provide immutable container tags. And this is really important for sites to revert any sort of update, because at some point there's going to be a bad software update. So it's important in any sort of DevOps or operational scheme to make sure that there is a way to go back to the previous state. And so there are a lot of new technologies and a lot of new ways of doing things that we're exploring in OSG Path. And so there's a lot of knowledge that has to be built in the organization and in the community, around the community as a whole. So one thing that my team does is we host bi-weekly Kubernetes hackathons. So we will have folks that we know are working on Kubernetes projects that we invite to these hackathons. We give them an introduction to Git Ops if that's something they're interested in. But otherwise, we kind of work on our own projects, which may be deployments within Kubernetes, working on the Kubernetes clusters themselves. And it's not just OSG staff that we invite. We've invited a lot of other folks that have been exploring Kubernetes and that are interested in making use of it. And one important thing I think is, other than that, because that's very, very kind of passive, is finding opportunities for Kubernetes-based projects that involve new teams and team members. Because unless Kubernetes or DevOps is part of their day-to-day work, it's hard for folks to set aside the time to really absorb that knowledge. And so getting a project where there is a common goal, you can put experts in the various technologies alongside folks that are new and maybe need to learn a bit more. You can put them alongside together to kind of share that knowledge amongst your teams. We also have, Kubernetes focused Slack channels that are very active. A lot of people asking questions and folks that are at varying levels of Kubernetes expertise, either chipping in or just kind of watching to learn how folks are solving things in the world. There's also opportunities for cross-pollinating with other groups in the consortium on Kubernetes and DevOps. So I think back in 2019 or 2018, the University of Chicago, it was the University of Chicago and UW-Madison. We had a couple of Kubernetes meetups, and this was kind of when we first started exploring Kubernetes. And so there was a lot of knowledge transfer and discussion, and we treated a lot of these as working meetings to work on particular projects to really advance the level of knowledge within our groups. And so that's the end of the talk. Hopefully it didn't go too far over. Are there any questions?